Well, guys, how are you? How's things going? Welcome to week 2 of quite possibly the strangest education I've ever provided. But I hope you guys are doing awesome and you are healthy and safe at home and eating some good food and and hanging out with the family. That's what we're doing, and it's actually kind of nice. It's kind of nice. We just kind of stay away from the public eye and keep our head down, and yeah, we're doing all right. And I hope you guys are doing really well as well. Your assignment 2s, they should be posted there. Today's Wednesday. They should be posted there tonight or tomorrow. Yeah, things are going well. So this PowerPoint here it's a bit of a doozy, but you're going to see a lot of repeat. We've covered, you're just going to see a lot of repeat, and eventually you're going to figure this course out and you're going to be able to pick out what's important and what's not important. So let's rock and roll, shall we? Again, you guys have seen this slide there before, oxidation and reduction. And if we start off with an alkane, just a plain Jane alkane, we oxidize it, turns into an alcohol. And in this case here, primary alcohol. And then if we continue oxidizing it, a primary alcohol changes into an aldehyde. And if we continue to oxidize this primary alcohol, going further than the aldehyde, we head into a carboxylic acid. And this is one of the topics there that we're going to cover there today, is aldehydes and carboxylic acids. Okay, and if this was a secondary alcohol, meaning the alcohol group was attached to a carbon that was attached to two other carbons, then it would only go to a ketone and then it would stop. Okay, and you look at the opposite of oxidation is reduction, where you remove an oxygen. Basically what it is. One reduction takes away one oxygen, another reduction takes away one of the oxygen's bonds here, and so on and so forth. The carbonyl group consists of a carbon, oxygen. It's very polar. You look at all the electrons right here. Oxygen has 4 of them up here 100% of the time, and it's got these 4 electrons right here that it's got maybe 80% of the time. So it's extremely polar, has a very electronegative oxygen atom, has partial positive carbon, right, and a partial negative oxygen. What do we got here? Today we're going to be dealing with aldehydes, ketones, carboxylic acids, and we're also going to hit esters a little bit. Okay, this carbonyl group is in all of them. Carbonyl group is a C double bonded to an O. Okay, aldehydes and ketones are basically the same banana, but an aldehyde, the carbonyl group is on the end. A ketone, the carbonyl group is in the middle. So if you have a look here, maybe you want to pause it and have a look, but this is what an aldehyde looks like, and you can see the schematic right here. Okay, I can blow that up. Look what I can do. And right here is your ketone with the carbonyl group in the middle. Carboxylic acid. Okay. Whoa, moving everything around. The carboxylic acid group has the carbonyl group on the end, and it also has an alcohol group on the end, making this whole side of the molecule very polar, because you've got a large amount of oxygens in there. Okay, so aldehyde, ketone, carboxylic acid. As we just showed you right there, usually it's if it's written in the in this form here, you will see it written as CHO. and that means an aldehyde. Written structurally is this. Written short form like this, if you see a ketone, it will be CO. And you remember how many bonds does carbon have? 4. So you see this carbon right here, it has 3 hydrogens, and that carbon is bonded to that carbon. So this carbon has 4. Well, this carbon doesn't have any hydrogens. So that tells you there's something is going on. It has to have 4 bonds. So the carbon is bonded to this carbon. It's also bonded to this carbon. It still needs 2 bonds. So therefore, chum chum. Okay, C double bond O as it is here. Generally, when we talk about solubility of these guys, organic chemistry, once you get in and around 4 or 5 carbons, that's the limit as far as solubility goes. It doesn't, like, you look at here, methanol, ethanol, propanol. These are your aldehyde, okay? And methanal. Al means aldehyde. And you have a very polar end, and you have a small number of carbons which are non-polar, but as long as if the number of carbons is relatively low, this sucker's going into water. Okay, because it's polar, because of this carbonyl group on the end. And then you see as we start to increase our number of carbons, we have propanol, which is an aldehyde with 3 carbons, prop. Here we have propanone, okay? And what happens here is things are starting to change a little bit because we're starting to increase the number of carbons. And these carbons, they are insoluble. They're completely non-polar. But the only reason that they're going into water is because of the carbonyl group. And you see here propanone, we have C double bond O. I think it's this one here. This is propanone right here. This is crazy polar, non-polar, but this thing still will go into water because my number of carbons is relatively low. But you'll see in and around 4 or 5, what happens is the insolubility of these non-polar carbons starts to take effect. And you see here what we've got. This is pentanal, okay, aldehyde with 5 carbons, and this is crazy polar, but it can't override the non-polarness of these guys here. And you have a look at 2-pentanone. This is a ketone with carbonyl group on the number 2, 5 carbons. Okay, pentanone, 2-pentanone. Why is there a 2 there? Because there actually is another configuration with another number. Can you figure it out? It would be 3-pentanone, and you'll see there that insoluble. So solubility somewhere around 4 and 5 for these guys. That's where it tends to drop off. What do we got here? The electronegative O atom of the carbonyl group in aldehyde and ketone forms the hydrogen bonds. And you'll see here, I'll blow this back up. And that's why these guys here are soluble in water up to about 5 carbons. Because if you can get hydrogen bonding, this thing's going into water. Practice. Indicate whether each is soluble or insoluble. Well, what do you think about that one? Just an alkane. Nada. Alright. Here we've got, what's this one called? Quick like a bunny. Ethanol. Sure it is. Low number of carbons and a polar side chain. Sure, that'll go. Okay. That'll go into water. What do we have here? I got 4 carbons with an aldehyde. Butanol should go. And here I've got propanone. That should go as well. Okay. Naming aldehydes, I've kind of Already alluded to this. It's basically the same as everything else. You'll remember there the most important slide. Please have those memorized. Meth, eth, prop, bute, pent, hep, hex, hept, oct, non, dec. You're not going to get anything higher than that. I might throw a non-ane at you, but know them, because that's it. Aldehydes are just al. And here we have methanal, ethanal, propanal. You notice there's no ones. An aldehyde, the aldehyde group is always on the end. So it'll always be on the one carbon. So you have a look here. Where's my methanal, ethanal, propanal? It's one propanal, sure. But if I put the aldehyde group on this side, isn't it still one propanal? Butanal, there isn't any numbers involved with aldehydes, all right, because they're always on the end. We'll see, but there will be we'll get there. I'll show you some tricks. So naming aldehydes, again, be careful of these ugly benzene side groups, and you'll have a look here. Like, you've got a benzene group here, and you've got an aldehyde group here. Who's the big boss? What is this thing going to be named after? Well, it's always going to be, if you had a choice between this, the benzene having the root, or the alcohol, or the aldehyde, or the carboxylic acid, that one there would have the root. So in this case here, benzaldehyde. I got some other ones here that I'll show you. Give the IUPAC name for the following aldehydes. So you have a look here. I got unos, dos, tres, cuatro, cinco. I got 5 carbon chain. Okay. Off my 5 carbon chain, I have an aldehyde group on the end, and I have a methyl group here on the 2 carbon. This guy here is the big boss. So this would be, okay, pentanal. And then this guy here would be 2-methyl pentanal. Have a look at this one here. Here I've got a benzene group. I got 2 chlorines coming off here. Here I have an aldehyde group. Okay, so what do you think is going on here? Show you. We'll do this in steps. And this is how I want you to do this. You've got to, remember I told you, when you're naming these, you got to name them from the back side and work forward. So here, we've got our pentanal. Good. Here, if you don't look at the chlorines here, you've seen this there before, that's benzaldehyde. Okay, let's move on. And this is going to be the number 1 carbon. This is going to be the number 2, 2-methyl pentanal. Look at this one here. Make it make sense. And you see how we've got the benzaldehyde. All right, that's our base. Now, you look at this. If you're going to place where are these chlorines? Well, this one here obviously has to be number 1. So you start counting from here, find your shortest side to the chlorines. So if this is number 1, 2, 3, 4. If I went the other way, 1, 2, 3, 4, 5, no good. So this one here, 1, 2, 3, 4. Sorry, that's 1. That is, that's number 1, 2, 3. Actually, that needs to be 3, 4. I'm going to change that. And I'll update that there on the PowerPoint there that you guys have. So that would be 1, 2, 3, 4, 5. 1, 2, 3, 4. That would be 3,4-dichlorobenzaldehyde. How do you like that, eh? Making changes on live TV. What do we got here? Never need to number the positioning of the aldehyde, as it was always be on the number 1 carbon. Okay, so that's how this one goes. What do we got here? Aldehyde and flavorings, yeah, there's lots of them. Almonds is benzaldehyde, vanilla, cinnamon. Okay, naming ketones, again, it's the same thing. The only difference is here you got to be careful with numbers. Because remember, if you put a number in front of that, then that means that there is the possibility of another configuration that requires another number. And you have a look at propanone. Ketone is a carbonyl group only in the middle. And that is the only configuration you're going to get. So there is no need for 2-propanone. Okay? And please know that there is the old school method. They call it dimethyl ketone. I'm not going to get you on that one. I'm just going after IUPAC. Okay, this one here, look at this, 2-butanone. I put this in there. Is that right or is that not right? There is no other configuration. That is only butanone. All right, so there is no number there as well. Just to go back here, why is it not 2-propanone? I think we've gone over that. So just be careful of your numbers. I like that question right there. Yeah, we've gone into that. Have a look at these names here. Again, same kind of thing. Find your longest chain. 1, 2, 3, 4, 5, 6. So you're looking at 2-hexanone. Get out of here, cat. Trying to do something. Cats. Anyway, let's go back here. That would be a 2-hexanone. 1, 2, shortest side, hexanone. What's going on over here? Now, this is not a benzene or anything like this. This is cyclopentane. So I got methyl groups coming off of here, and I've got a ketone coming off of here. So maybe this might be cyclopentanone. Would this be your number 1 carbon? Making this number 2, number 3. All right, see if you can get these. You can pause it and try it out anytime. Okay, here we go. Hexanone, pentanone, 2-hexanone. There's your pentanone. And you notice it's not 1 pentanone because you don't have to. Pentanone, that tells you there that this is a number 1 carbon. And here we have 2,3-dimethyl cyclopentanone. And as we said here, there, I didn't really get to it, but 4-methyl 2-hexanone. Hopefully that makes sense. All right. Pause this thing anytime and have a look at it again and work it all out. What else we got here? This is the old school name. I'm not interested in this. You won't see any questions on methyl ethyl ketone. I'm not interested in that. So let's. I would normally, but since things have gotten so screwed up over the past, I don't know, us not having classes anymore. So yeah, don't worry about that. You're good. What have we got here? Any IUPACs, I like it. Okay, so you have here 1-phenylethanone. Okay, you have a look at it. 1-phenylethanone. There's your F group. Okay, and there's your phenyl group, phenylethanone. Phenylethanone. And this came from a textbook. You can see that it's just taken there from the teacher's slide. I would question whether, I didn't do this, but I would question whether they even need to put a 1 there. Because if this carbonyl group was on this side, it wouldn't be an one anymore. It would be an aldehyde, right? So, again, it is what it is, right? Phenylethanone. What do we got here? 1 phenyl, 1 propanone. Now, this one here, I like it. Now, because what we have here is you could have a ketone on this group, or you could have a ketone on this group here. All right, so definitely I like the 1 propanone there. Write the structure of 3-heptanone. 3-heptanone. Okay, so how do you recognize? You're not going to have to draw these, but you're going to have to be able to recognize 1 out of 4, right? A, B, C, D. So how do you do this? Start with your heptanone. All right, and draw your 7 carbons. 1, 2, 3, 4, 5. 3-heptanone. Give the IUPAC names for the following. You can pause this video right now. Or we can just go on to the slide. And 1, 2, 3, 4, 5, 6, 7, 8. So it's got to be octane, but we've got this ketone here. So that would be 1, 2, 3, 4. It's got to be a 4-octanone. But then we've got a methyl group and a bromo group. Which one would go first? Bromo. And what do we got here? 1, 2, 3, 4, 5. This is pentane, but we've got an aldehyde group, so that would be pentanal. But we've got a chlorine and another chlorine, so you're looking at a dichloro. This would be your number 1 carbon. Okay, and let's have a look. There we go. Have a look at those. Pause it at any time. Make it make sense. You guys are a good group. I'm not worried. Just get it done. Write the structure of cyclohexanone. Again, I'm worried. The one, I just said I wasn't worried. I'm not worried about that. Just do not, or just remember that this is not benzene. Okay, benzene is a whole different ball game. These cyclohexane, cyclopentane, cyclobutane, carbon has 4 bonds. So this carbon right here has 1, 2, and then it's got 2 hydrogens coming off of it here. It's got 4 bonds. If you look at benzene, it's got the electrons in the middle. It only has 1 hydrogen coming off of. All right. So this is cyclohexanone. Common ketones, nail polish remover. Okay, acetone has a very distinct smell. It's a great solvent for removing things. Okay. Look at this one. Butanedione. See if I can blow that up. Butanedione. 1, 2, 3, 4 carbons. All right. 2 ketones. No number. Butanedione. Found in margarine. Ugh. Oxidation of aldehydes. You've seen this already. We covered this there a couple weeks ago. There's your primary alcohol oxidized to an ethanol or an aldehyde. Further oxidation. Okay, there's your carboxylic acid.
Yes, it's Superman.
Why does he always text when I'm in the middle of class? Here we've got a secondary alcohol. Oxidize that to a ketone. Further oxidize, no go. Carboxylic acids. All right. These are organic compounds that contain the carboxyl functional group. Okay, so the carboxyl group is the carbonyl group and an alcohol group. Okay, very polar. Here is acetic acid. All right, vinegar. Here is, what do we got here? Benzoic acid. Okay, and you'll see here benzoic acid, kind of like benzaldehyde. Okay, you notice that there was no benzone. There's no ketone coming off of a benzene, because how many bonds are coming off a benzene? One. So if we go back to this one here was cyclohexanone, because there's 2 bonds coming off to an oxygen. Well, benzene has only got 1, so it can't have an one coming off of, straight off of a benzene. Naming these guys here, these ones here, again, it's just another pattern to follow, walk in the same path. Follow your, find your largest chain, when in this case here is 5, and it's a carboxyl group, and it would be pentanoic, oic acid, that's the COOH, and that is always on the end, so that will be your number 1 carbon, 1, 2, 3, 3-methyl pentanoic acid. Yeah, you know, you're going to see some slides here with the alpha, beta, gamma, delta signatures on them. I'm not too worried about those. I'm not going to put any on the test, but I don't know. You might see them later. I'm not going to test you on it. It's not important. I would normally, but what it means is you have your carboxylic acid here. The next carbon over, if something is alpha, the next carbon over would be a beta. The next carbon over, gamma. You know what? Just name them by numbers. That's all I'm interested in. Okay. So anything to do with alpha, beta, gamma, I'm not too interested in. You might see a slide or 2 of this here, but I wouldn't put anything on a test like that. Right formula for 3-chloro, 4-methyl hexanoic acid, and 2-amino butanoic acid. So if you want to take 2 seconds, you can pause the video, try this out, okay? And in the spirit and magic of cinema, welcome back. Hopefully there you guys have attempted these 2. And here we go. Here we've got, now always go from the back side. Here I've got hexanoic acid. All right. 1, 2, 3, 4, 5, 6. Okay, so this is my number 1 carbon. This is hexanoic acid. I have a chloro and a methane. Chloro comes before M, so it'll be 3-chloro, 4-methyl hexanoic acid. And no need to tell me where the acid is, because it's always in the 1 carbon. Alpha amino butyric acid. This is the old school name. Don't even worry about it. Okay, this is 2-amino butanoic acid. So butanoic acid, 1, 2, 3, 4 carbs. There's my butanoic acid. Carbon 1, carbon 2, 2-amino butanoic acid. Okay. Just some interesting information. There might be one question on here. Methanoic acid. I don't know if you guys have ever seen that TV show there, The Kings of Pain. If you have a weak stomach, do not watch it. Please consult your doctor before watching it. But it's these guys here who just go out and purposely, for the point of science, so they say, go out and get bit by all these strange animals. And they one of them there was red army ants. And I think all ants have formic acid as kind of a bite, but they just get progressively stronger. I think like red army ants, these ones here, and they can leave a nasty sting, and that's called formic acid, old school name, methanoic acid. So ethanoic acid is acetic acid, butanoic acid, butterfat, hexanoic, goat. Jeez, goat has a lot of them here, eh? Decanoic acid, and don't expect anything past this, but palm oil, which tends to be the one of the most horrible things ever devised as far as the food industry goes, decimating our planet. Hexadecanoic acid, beef fat. You know, animal fat is solid at room temperature, okay, not a liquid. Therefore, in your body there, it's circulating around your blood as a solid, and therefore can lead to heart disease. But anything less than 4 or 5 carbons will not be bad in the blood. What do we got here now? Again, talking about solubility, when we're talking about carboxylic acids, 1 to 4, very soluble, and here we start to getting into they're slightly soluble, and you see here we even go up to 7 carbons here for the carboxylic acid because it's so much more polar than the aldehyde of the ketone. It's got a whole other oxygen on there. So therefore now, as aldehydes and ketones, they became insoluble at what, 5? These guys here can go up to 7, 8, and they are insoluble. So 8 carbons, then now this thing becomes insoluble. Boiling points tend to be very high because of hydrogen bonding. And you think about that. The more hydrogen bonding, the more this thing acts like water. And water has so much hydrogen bonding that it boils at 100 degrees Celsius, which in nature is very, very high. Very high. All right? Because water has such a cohesive force to it. Well, if you put in a carboxylic acid, like mix it with water, or just a carboxylic acid by itself, it will have a relatively high boiling point because of this hydrogen bonding. What do we got here? When you put these acids into water, they will ionize. The hydrogen, let me see here, I'll blow it up. You see here, you put acetic acid into water. Generally, this hydrogen will jump off and create hydronium. Okay? It is an acid. Is it a strong acid? No. It's not like hydrochloric acid or sulfuric acid where remember 100% ionization? This one here is one of those 50-50 guys. But it's really not 50-50. It's like 98-2. Okay, and but that's how this one goes. Okay, it's a weak acid. What do we got here? Carboxylic acids are released in the blood by the liver in an excessive amount during ketoacidosis, which is a condition associated with uncontrolled diabetes. Good words there. Hopefully they've showed up there in your bio class. Normal amounts of carboxylic acid can be controlled by blood buffers. Okay, not too worried about any of that. What do we got here? Major types of carboxylic acids. These ones here are interesting. Oleic acid. Look at all that. Just long chains with a carboxylic acid in the end. You've seen this, benzoic acid. I like this one, a dicarboxylic acid. Oxalic acid. Where have you seen that one there before? It's a dicarboxylic acid. Lactic acid from the milk, okay, and we call this a hydroxy acid because you have a carboxylic acid group, and you have an alcohol group within there. And one of the most famous of them all is the amino acid. Okay, these guys here we're going to get into there in a little bit, and these guys are interesting because they have an acid group on one side and a base group on the other. So we'll get into those. That's why those guys are fantastic. As we just said there, the amino acids, they have the carboxyl group as well as the amino group. Okay, you'll know there that ammonia can take on an extra hydrogen and become ammonium, can become a base. So these the carboxylic acid acts as an acid. This guy here acts as a base. Amino acid units are the building blocks of proteins, as we all know, and there are approximately 20 amino acids which have different R groups. And if I had a blackboard, you see, like, all of these amino acids, you see it's got the acid side, it's got the base side, they all have a hydrogen sitting there, and then they all have a different R group. Now what this is, this could be a polar functional group, it could be a non-polar functional group, it could be this, it could be that. There's 20 different variations, more than 20, and depending upon this R group, you start linking amino acids together. Usually they're in water, right? Like blood or whatever, cytoplasm or whatever. And so it's water-based. So if there's non-polar R groups, like a whole stretch of them, then what will happen is these amino acids will start to fold and contort to get that R group away from the water. So on the inside of a protein, you'll have these non-polar middles that have folded and contorted themselves because of the body over 1 billion years of evolution has realized there that if I have this sequence of amino acids with all non-polar R groups, then therefore now I will get this certain three-dimensional configuration, which is exactly what I needed there to unlock this certain protein in whatever. Okay, so amino acids there, they are highly complex, and there's only 20 of them. Write the structure formulas of the following: a dicarboxylic acid with 3 carbons. Okay, an alpha amino, a 2 amino acid there with 3 carbons. Write any type of just a normal amino acid, and this is what you get right here. Okay, so what do we got? Again, we're walking over the same carpet. How do you make a carboxylic acid? Well, you need a primary alcohol, oxidize it, aldehyde, continue to oxidize it, changes it into a carboxylic acid. So you have a look here. Here I have benzyl, okay, and we have now created benzoic acid. So let's just keep on moving, shall we? What primary alcohol can be oxidized to form pentanoic acid? I like this kind of a question because I'm kind of giving you the answer and I'm asking you to work backwards. What primary alcohol can be oxidized to form pentanoic acid? Well, pentanoic acid, carboxylic acid, before it became pentanoic acid, it was pentanal, and before that, okay, it was 1-pentanol. Okay. What do we got here now? We're right on the tail stretch right here. There's only a couple more slides left, and we're just zooming through this one right here. If we mix a carboxylic acid and an alcohol in acid, we get what's called an ester. And that is this carbonyl group again, but that same carbon is bonded to another O, which is then bonded to another R chain. Okay. Naming this, the IUPAC name for esters. Now, I want to show you this right here. there's two sides to this chain. This is your ester group. This is how you're going to name this thing. But there, if you cut it right here, you've got this side that contains the carbonyl group. And then you've got this side here that does not. It just has a single oxygen. This guy here has the double oxygen. Okay? So, whichever side has the double oxygen, this one here is going to go last. Has nothing to do with the number of carbons on this side, nothing to do with the number of carbons on this side. So in this case here, you see, here I have an ethyl group with the carbonyl group, and here I have a methyl group with this other one. So it would be called methyl ethanoate. O8 tells me that it is an ester. Methyl ethanoate. Whichever side has the carbonyl group goes last. Let's have a look here. So, what do we got here? Have a look here. Here I have an ester. First thing identify, it's an ester. So 1, 2, 3 is with the carbonyl group, so that'll be a propanoate. And here I have a methyl group, methyl propanoate. See, not so bad. Have a look here. Here I have an ester. Which side has the alkyl group? 1, 2, 3, 4. So that's bute. So that would be butanoate. 1, 2, 3. Propyl butanoate. What do we have here? We have an ester. Which side has the carbonyl group? Okay, here I have ethanoate. What do you think is going to go on here? Phenyl ethanoate, propyl butanoate. Occurrence and physical properties of esters. This one was our lab there that we missed, lab 5. Remember I was telling you there about the Parmesan cheese lab? And it's all right though. There are lots of good smells, but you guys are pretty good at esters now because you guys did that lab, which was a lot of work on it. So anyway, I won't keep you guys any further. You guys are doing great. Let me know if you guys are having any issues, but I don't anticipate any. You guys are doing just fine. Be safe, be well, and we'll chat with you again.